We're about to start. Thank you very much, everyone, for coming here. It's a pleasure for Glovo to be doing meetups again. I don't know if you, before COVID, we were already starting to do some meetups. Raise your hands if you came to the old offices in Glovo for doing meetups in like 2-3 years ago. Cool. Today we are focusing in modern Android development, and by modern we say not dealing with basic stuff. I don't know if you remember the old time, even before the app support and all of this, that you need to deal with a lot of stuff. That why the hell do I need to learn how to operate the camera in different versions? Android, can you stop changing the API every time? So Jetpack is adding a lot of help. How many of you is using at least one Jetpack library in your applications? More than 2? More than 5? Cool. Today we are going to be focusing, maybe you know, in Glovo, we have 2 different applications, one for customers, one for couriers. We have representatives for both of them, Angelo for courier and Gianmarco for customer. Angelo is going to start. He is going to be talking about Jetpack Compose, which is a really exciting way to say goodbye to XML UIs, probably. I know, Angelo, you play a lot to Magic the Gathering. And I think composing decks and crafting decks is similar to crafting the patient for the XMLs. Gianmarco is going to be talking about Hilt, how we integrate Hilt in Glovo. And maybe you don't know, but Gianmarco has a big collection of JoJo's. Probably for you, Dependency is just throwing JoJo's here and there, right? We are going to do more meetups in Glovo in the next months. And today we have a special surprise for all of you because we are happy to be you here. We have some swag that you can collect later. And also we have some promo codes. And the girl with the white and black stripes and the girl with the Glovo t-shirt, they are going to be giving you, Tania and Silvia, they are going to give you the promo codes as you go for the pizzas and beers. And we hope to have some networking. Now, please warm clap for Angelo.
Hello. Yeah. Okay, thanks for the presentation. I'm Angelo, and I'm gonna show you some things about Jetpack Compose. And I think you already might know about this framework. It was only recently introduced by Google to help us building UIs for Android apps. So yeah, the talk is called From Zero to Hero because, like, if you don't know anything about Compose, by the end of it, you will be able to write at least some basic interfaces with some logic to it. And so let's start with what's the status quo for mobile UI today. And when you in today's app, what you would expect, it's not only an user interface to deliver to complete a task, but you want to focus on the experiences, you want nice animations, you want a good design system, and you want to do that in a very fast way. And the Android UI system actually is not the best thing you can find. You could find at least 1 year ago in the market, and in the time new UI frameworks have been developed in other platforms, and that basically helps you building these such UIs, right? So what's Compose? So the first answer is that it's a declarative UI framework. Then I think your next question would be, what's a declarative UI framework? And in order to understand that, let me explain this to you with an example. The example is, let's say that you have your UI, it's an envelope, and you want for this envelope to be empty when you don't have any messages in your email client, right? If you receive some, you want to display a yellow sheet with a counter with the number of messages that you received. And if you have more than 99, you want to be fancier and you want to display like a small fire, right? Just check your mailbox as soon as possible. In the imperative UI, with imperative UI framework, what you do is to describe your UI, but at the same time, you had to manage the state associated to it. So for example, what you saw before was just a super easy UI, right? Piece of UI, but like the code that you have to write to handle this couple of states is kind of not complex, but perhaps it's not like the easiest thing to maintain, right? And you just wanted to, place a couple of badges and place a fire icon and so on and so forth. With declarative UI, what you describe is actually, it's only the structure. Like you can say that in order to have what you saw before, you want an envelope, and that has some properties like only display the fire when the count is more than is over 90 and 99. Yeah, paper as well. And if you have more than 0 messages, then you want also display a badge. As you can see here, there is something missing, which is the state management. Like you don't have to do, like you don't have to write that bunch of ifs that if blocks that you saw before. So how do you use Compose? So Compose provides you, in order to obtain that, you can use some basics and like text button, text field, checkboxes. These are basically your building blocks. Yeah, a text corresponds to a text view, button to the old button view, and so on and so forth. Then you can arrange all these things together using like other composable that are, for example, like box, columns, and row. Box is basically a substitute for, it's a replacement for a frame layout, column for a linear layout, vertically with a vertical orientation, row with a horizontal, and so on and so forth. And yeah, so you have these building blocks, right? Then you might ask to yourself, okay, I have this, I dispose them in layouts. What if I want to tweak their appearances? Then in order to do that, use something called modifier. Modifier is something, it's basically a thing that you pass to your composable, and that allows you to tweak the composable's appearance and the size, layout, behavior. You can add additional behavior, and also like you can make an element clickable, scrollable, and so on and so forth. These are the basics, but like let's see how all these things together are, like how all these things assemble, right? And the best example to see that is something that I think is a pain point for all developers that are trying to write a recycle view, right? So like a list of items, because usually you need to write a lot of boilerplate code just to have a list of items in a row, right, or in a column. And yeah, so and it basically looks like this. So a composable is nothing more than a function, right? And these building blocks that we saw before, they are also function. That modifier that we saw that tweaks the appearance is a parameter that you pass to this function. You basically put all these things together by composing them. This is why it's called compose, right? For example, this super easy this example is super easy to follow, even if you don't have much knowledge. For example, we want to have a list, right? Instead of using recycle view, adapters, and so on and so forth, you just have a column. And I want for this column to have some padding. So all the children, all the texts that you see down in the 4 will have this padding around, and you want for it to be scrollable so that you can scroll it back up and down. Of course, and orientation is going to be vertical, right? Then how can I display multiple elements? You can just use a for loop, like anybody knows a for loop. Not anybody, but like the engineers knows a for loop. And yeah, and then basically, like, for example, let's say you take a list of user. For each list of user, I want to display a text with the username. Super easy to understand. So before I said that Compose is a UI framework, actually that's part of the truth. Because you might start wondering how this will actually become UI, right? The truth is that Compose is more than that. It's actually also a framework to build and maintain tree structures. So for example, what happens is that when you write such a piece of code, like a column with a text and a button that contains a text, what is going to happen is that the code that you write will be manipulated by the compiler with a compiler plugin, and it'll become a code that is able to assemble that tree representation over there. If you take a look into it, it's exactly the hierarchy that you see on the left, but represented in terms of a graph. And then from there, we materialize the tree into pieces of UI, so that every time that a function is called and node is traversed in the graph, we're going to emit just a piece of UI. So for example, the column has 2 children, and the text will emit a text field. Let's say something like it's going to draw a text, something like a text field, and a text view, sorry. A button is going to display a button, and within it, there's going to be this text view. So before moving on, in order to understand what we basically saw here, let's throw some terminology around. So what's a state? It's a property or a set of property that describes a system. In this case, is your UI. What's composition? Because like these words are very much used in the even in the Compose documentation. For composition, we mean the act of creating such a tree. And recomposition is the act to rebuild the tree given a tree, right? So let's say you create it once, and then you want basically to update it, and like each update will modify the tree will modify the UI state. And then the composer is something that actually you don't see, but is added by the compiler that emits the UI pieces that you want to draw, right? Why is this important? Why this tree representation is very powerful, and why this allows you to have very nested UIs without having a performance hit? Because as you can see here, let's say that you have my state, that is a data class that contains username and an address. And at some point, and this basically, this my state is passed to a composable called my screen that draws something into it. Just take property from a state and use them to draw UI elements. That's going to be a profile header, for example, and an address box. Let's say that username changes, right? So you don't want to redraw all the UI elements associated to an address box, right? Because it didn't change. Why should I redraw them? So basically, so using the tree composition, like the composer could be smart enough to understand what's changing, what didn't change, and redraw that part accordingly. Having this, as you can see, unless you are always redrawing the state fully from scratches, you're gonna have good performances, even if you have a very big tree, right? Then before moving on, let's also introduce some other concepts that are very important with Compose. One of them is called state hoisting. So state hoisting is the pattern that consists into moving the state outside an entity, right? Outside a composable, so that it becomes stateless. Why it's important for the compose to become stateless? It's because basically being stateless favors composition, right? Because you're gonna have a more reusable component that you can use in different parts of the UI, and the state is gonna be fueled from outside. So you can reuse, for example, this profile header in different places, and that will favor reusability and testability as well. For example, like things that you want to do and composable is like not reading directly from the view model, right? But receiving the state from outside. So you basically, by doing so, you decouple your pieces of UI with the logic, let's say the presentation implementation that you have in your own app. That's also partially true though, because like composable, as you saw before, it's a tree, right? There's going to be a place, and there's going to be, for example, this mutable state of my state where you actually want to read from the view model. But for everything that comes down this path, you don't want to do that. You don't want to do that any longer, right? You just want to pass pieces of state around in order to favor to help compose drawing the UI. This holds for actions as well, because this is just decoupling, right? We are decoupling the state, we also decouple the actions, so that instead of calling the view model directly, it's better to hoist the actions as well and just expose a parameter that takes in a lambda. By doing so, you can reuse that in different places, and also this becomes especially helpful when you are testing the composable. Actually, another thing that it's not done here, it's also the modifier itself. It's always good to hoist that as well, so that you could use the modifier in tests to identify your composable. So let's introduce other concepts that are also part of Compose. One is observer pattern. I think everybody knows that. It's just when you want to like listen to a source of events and notify when and notify the dependents, the subscribers when the state changes, right? And the other one is memoization. That is not to be confused with memorization. I don't know if it's an English word, but it's memoization. So that's a technique that is used when you want to store the result of a function, because the function is too heavy, let's say, and you don't want to compute it again each time. You just want to cache its result and reuse it when the inputs are exactly the same ones, right? And that assumes, of course, that your function doesn't have side effects, right? It needs to be pure in order to do that, because you want to guarantee 100% that for the same inputs, you're going to receive the same output. And composables, since they're using a side effect to emitting UI, but that's the only side effect that Compose uses, that it kind of guarantees that. So let's say that we have the view from before, and you want to attach a state to it. How can you let Compose observe the state and trigger a recomposition that we said is creating a new tree and a new UI out of it? We just used a function, another composable function that's called mutable state of, right? And it allows Compose to observe a snapshot of a state and like trigger recomposition each time something changes. You can also interact with flows and observables with some utility functions that are called collect as a state, observe as a state. And then one other thing you want to do, you might ask, okay, functions are actually stateless, right? If you call them over and over, they won't remember what happened before, right? So like if you have, even if you have a mutable state in your composable and you are always reading from that state, if you call two functions then into different times, perhaps you're gonna basically reset that state over and over, but you want to preserve your UI state, right? For that, you can use another composable function that is called remember. And let's see how these things come together. Yeah, let's see an example, right? And so the example is my screen, and you have a name, and the name is it's part of the state. You have basically an external state, which is my state that comes from outside, and the internal state that is the name. And this name is a mutable state of. So basically we are saying, okay, Compose, have a look at this, like look at the snapshots coming from this name and update, like recall this function again when something changes. And if the name is not empty, you want to display a text with the name. And you want to display the name within the text field, right? Yeah, because like, yeah, you don't want you want to type like that everything you type stays there, doesn't go away. And every time how we update it, the outline text field, which is a composable, exposes, as you can see, this pattern is used in the API as well. It exposes the action outside, it hoists the action outside so that you can change that. And every time it changes, this is going to be automatically updated. What it means to be automatically updated means that this whole function will be called again. But if you had an external state, for example, as you can see, my state here was also setting the color of the column. We want for that color to, we want that if that color changes, name doesn't change, right? Because we want to remember what was the latest state of name, and we want to reuse that. So we basically, every time the background changes and I typed in Angelo in this outline text field, yeah, that basically that state, it's still preserved, right? Yeah, there are a few things to remember. Just wanted to do a pun. So remembers things, so stores the results across recomposition. What are recompositions? They are the times, like the updates of the tree that represents the UI, right? We saw that before, but it doesn't remember things across configuration changes. For that, we would need to use another composable that is called remember savable, and also you can pass a key to remember so that the value that is stored inside the composer's table, it doesn't happen only during composition. So you don't store it only once and remember for the whole life cycle of the UI, right? You can pass a key. For example, here you can pass my state, and every time my state changes, that computation inside remember will be updated. So you can update even results that have been cached inside the composable, right? Okay, then now let's see what are side effects. Side effects are actions that escape the function scope, right? They do something unexpected, and that basically kind of breaks the purity of a function, let's say. But in this case, since we don't have control over what are emitted from the composable in terms of UI, we cannot interfere with that operation because it appears, the code to enable that appears only after the code is compiled. It should be kind of safe to use side effects in composable, side effects that are affecting your business logic, right? For example, let's see this composable here. We have again a screen state coming from outside. We have a scrolling sheet that is something that scrolls, perhaps, and you have a scroll position. You want to remember that scroll position, because if you scroll a little bit and then you call again this function, you want to keep the scrolling state, but you want to notify, you want to execute some logic only when the scroll position changes. So let's imagine like you have one invocation and then scroll position changes from nothing to 0, you print a line, right? Then scroll position doesn't change, remains 0, but the state outside changes multiple times, let's say 100 times. You don't want to execute again that print line because scroll position didn't change. You want to do it only when that happened. Then that launched effect, it's very similar to what we saw before with the remember. So it only gets triggered when the scroll position changes and executes the business logic inside a coroutine. This coroutine, as you might have figured, can outlive the composable, but actually Composes handles that for you. So it runs in its own coroutine scope. But if the composable leaves the composition as is, as in the node is removed from the tree, so the UI disappears from the screen, that action inside of the launched effect gets automatically disposed. So you're not gonna have a memory leak. Yeah, that's composition. And what about, like, what if you want to do stuff like subscribing to an observable or a flow, right? And then dispose that subscription when this composable leaves the screen, when the UI disappears. In that case, you can use this disposable effect that allows you to, it's basically getting called when the key that you are passing gets updated. Let's say the observable is only created once in your scope, perhaps injected with Hilt. And then when you want just to listen to these events while the UI is on the screen, when it gets disposed, like it gets removed from the screen, from your tree, then that disposable.dispose, that part in the undisposed lambda will be executed. So you won't, even here, you will be able to go back to your stream, dispose it, or to your resources or whatever you wanted to dispose, and dispose it and prevent memory leaks. Okay, then you see more or less how to build things, to build simple things, how to remember the state, how to remember the state, how to observe it, and it's pretty much it. You can basically start playing around with it. It's only a matter of putting things together and do your own layout, declare your own state, and listen to your view model live data or observable or whatever. But what if you want to test things with Compose? Like perhaps you want to ship code in production and you want to write tests for it. The good news is that Compose comes with APIs that allows you to find, assert, and trigger actions over the composable. The cool thing is that it's interoperable with Espresso. So you can use Espresso, you can mix Espresso APIs and Compose's APIs, and it works, which is not like something to get to that is given nowadays. And it works with Roboelectric too. And you can do that pretty easily because what you do, like when you do tests, you are not testing like full-fledged UI, you are testing the tree. So you don't really need the UI part, right? You can assert over that. So test APIs. How can you test things in Compose? So you need to create your own Compose test rule within your test, right? Set your content. So let's say you are testing a column with 2 texts into it. Then you create this Compose test rule. Now we're gonna see an example. You set this composable instead of it, and then you use some methods from this Compose test rule, like on node with text, or node with test tag, to select a specific node in the tree. Then you can use assertion methods like assert is displayed, assert is exist. They both test whether a view is inside your tree, is part of the composition, for example, but it's not visible, while the second asserts that the view is not there at all, that there is no node in the tree that you saw before, right? And then you can execute actions like perform click, perform text input. You can do really crazy stuff with these things. I'm gonna see an example soon. This is an example. This is actually production code. So I don't know whether it's legal for me to show this. I think yes. But basically what we are doing here, it's super easy. We have basically like a contextual menu, which is a composable. They are functions, right? It can be everything. And it basically accepts a list of contextual menu options that are, let's say, some texts, right, with a button. Every time you click on it, you want to execute a Lambda that is like that reacts to that. What you need to do is to place this whole composable within the compose test rule with set content. Then you identify all the texts that have option 1 and option 2, which is actually exactly what you are setting in the test, and you perform a click on it. And then you check whether the 2 values, they changed from false to true. And if that happened, means that basically the Lambda associated to the click, there is another composable inside this text menu, contextual text menu, is actually called. Then you can even do, I said before that you can even do crazier stuff. For example, this is another production code test copy pasted into the presentation. Basically, we have this so-called draggable sheet, which is something like a bottom sheet. And this initial state is collapsed. Then you can you set the content, right? Which is that's content that is setting this draggable sheet with this state. Then you assert that the header and the body are not there because the initial state is collapsed, you don't see anything. Then you perform a touch input, which is wipe up. So basically you are literally swiping up. You wait, you call run on idle in the compose test rule to just wait for the animation to settle in. And then you assert that both things are displayed. This is actually, doesn't look like, but it's a rather complex text that is expressed in a very simple way. It's very, very similar to pseudocode. I could explain the same thing by writing the same thing and it wouldn't be Kotlin code, but actual code. And yeah, I think this is it. I hope you enjoyed it. Yeah, and now I think if you have some questions, now it's the time for the questions. So you can go with the questions.
Hey, so thank you for a nice presentation. So my question is like, at which parts of Glovo apps you currently use Compose, and like if you can quantify somehow how many screens or how many places already uses Compose for you in production?
Okay, so we use Compose in the Courier app. We have a screen that is called delivery flow, basically. That it's what the courier used to deliver a package from point A from the store to the client, to the customer's house. That whole screen, it's only one screen, but it's full of composable. It's basically a map that has some cards into it. Each card represents the place when you need to be, and it represents the action that you need to perform in order to accomplish the delivery. For example, picking up an item, scanning the price, and deliver that to the client. This whole thing is done in Compose. It's actually it was our test drive. We basically had to we had this project to rewrite the new delivery flow from scratches, and basically we took the opportunity to do that in Compose, and this worked quite well for us. We were able to basically build the whole thing in approximately 2 months, which is it's a lot of code. And for what it comes to the other places, that we have some other places in the app, and we use basically Compose with the compatibility layer. Something that I didn't show. Actually, there are some complex things that I didn't show. I mean, compatibility, it's not really complex, but you can basically wrap your Compose. You can use an abstract Compose view, so-called, right? Where you can place composable inside of it. So if you have a composable, let's say draggable sheet, and you want to expose it from the view system, you can basically wrap that composable in this abstract Compose view, and you will be able to reference it in XML and control its state from the code, like you would do with the old view system. And we use that in different places because basically we created this design system that has some buttons, texts, some design elements, and these are the design elements are used in Compose in places where Compose is, like delivery flow, and with the compatibility layer all around the project. Yeah, but basically the goal is going to be to make the app more Compose friendly over time, and you can do that thanks to these compatibility APIs as well.
Hello. In the last test that you showed, is it possible to turn off the animations instead of doing run on idle?
Yes, it's possible even to control animations with Compose, because okay, Compose exposes something called monotonic clock. Basically, like you can even access the clock and like control the animations. You can even test that animations are basically passing through a certain amount of states. We haven't experimented a lot with that, but I know that it's definitely possible to turn them off, control them, do whatever you want with them. There you have more control over that than with Espresso, for example.
Thank you.
Thanks. Hey, great presentation. Thank you. In an earlier slide, you had said like, you don't need to use recycle views anymore. And here's an example of a list. I think you had like my list, and like you're passing users in, you're just doing text fields. Do you know if that does the same optimizations that a recycle view would do, in the sense that like with UI reuse, and how you would achieve that same optimization in Compose?
Yes, basically there are two ways to basically have a recycler view kind of view. One is basically just having a column with texts into it, and you apply the modifier. Another one is to use something called lazy column, and then lazy column applies more or less this optimization that the recycler view applies to the views, like recycling them. It's if you don't need, so Compose is very efficient because you have this tree kind of structure that it composes, it creates. And I think even if you have a lot of views, you're gonna have good performance anyhow. So if you have a view that is a list, and it's not an infinite scrolling list, it's just a list of a limited amount of elements, you can just I think it's enough to just use a column with a modifier scrollable attached to it. Otherwise, you can use this lazy column or lazy row that is a replacement for the recycler view. Okay, yeah, if you have more questions, I'm going to be around so you can poke at my shoulder anytime. Thank you.
Those who joined later on the left, feel free to come to the center. So we are like more centralized.
Hello, everyone. I am Gianmarco, and my voice is not really cooperating today, so please bear with me. So I work I've been in Glovo for a couple of years, and these days I work in the customer core experience team. So we basically help other teams working on the customer app. And one of the projects we have, one of the smaller projects we have, was actually introducing Hilt in the customer app so that other developers could use it. So in this presentation, I wanted to talk to you about what we learned, about Hilt, and in practice, how it works and why you should use it. So yes, this is the agenda. We will talk about the promises that Hilt makes, then how it works, and then some usages in production and in testing. So this is when you ask yourself why Hilt, you should look at the documentation and see what are they promising you. So this is what you can get from the actual Dagger documentation at the Hilt section. So they promise to give you a simplified infrastructure for Dagger code and creating a set of standard components and scopes so that you can directly use them. And then they also promise an easy way to swap bindings depending on the build type. So let's see how Hilt helps in these regards. So I call this section components, and I will explain why. So when people talk about Hilt, they say Hilt is a new dependency injection library. I don't fully agree. I mean, Hilt is a new dependency injection library if it's a library. I mean, you add it to your Gradle file, but in practice, I mean, when you say new, it's not really that new because most of it is just Dagger. Most concepts are just Dagger concept. Hilt is a companion, which is helping you dealing with Dagger. So, and when you ask me and what is actually Hilt, Hilt to me is a component manager. So a component, when I say component, I mean it in the Dagger sense. So just a refresher, a component in Dagger is a container for dependencies. So is the way you communicate to Dagger. So you have this dependency graph. How do you retrieve dependencies? How do you actually inject your classes through a component? And this is a small example, a small snippet. If you ever wrote a component, you know that you need to write an interface, add an annotation, and then you have a set of functions that you define and Dagger then fills. So these functions will be the entry point for you to inject dependencies or to retrieve dependencies. For example, in this case, the repository function will be used by you if you want to retrieve a repository manually, similar to a service locator. Or the inject functions is a way for you to pass a class and then let Dagger inject stuff into that class. And if you remember, in the early days when we started using Dagger, we basically had a huge list of inject functions where you passed activities, fragments, so that when the activity is created, you call this function, and then your activity was injected. So this is just Dagger concept, a component. But again, Hilt is at its core, at least from my point of view, is a component manager. So now let's see what actually Hilt provides. And this is the first part, is a hierarchy of components that are already done. You don't need to do anything. You don't need to write components. These are components that are already built by Hilt. You just need to use them. What does it mean that this is a hierarchy? It means that every node in the hierarchy will inherit dependencies from upper nodes, from parents. So if you are, for example, in the activity component, if you are injecting the activity, actually Hilt is injecting the activity through the activity component, then you will be able to inject whatever is in the activity component, but also other dependencies that are in the activity retain component or in the singleton component, because they are parents. So, and as you can see, almost all components are named after an Android class, apart from the singleton component, but the singleton component is associated still to the application, since the application is a singleton in a process. So the first thing to say about components in Hilt, and this is one of the most important things to say, is that they are monolithic. And by this, I mean that you have only one component for all your activities. You have another component for all your fragments and so on. So let's say in this snippet, I'm saying that foo needs to be associated to the activity component. So this means that foo will be injectable in all activities and all sub components, so in fragments and so on. So there is no way in Hilt to say foo needs to be available only for main activity, only for activity X, only for activity Y. This is not possible in Hilt. So this is the meaning of monolithic. There is only one component. And I want to be extra clear about what I mean. When I say one component, I mean that there is one definition of the component. There is one class representing the component, but then each time you need the component, you need to use the component to inject stuff, you will get a new instance. I mean, not you directly because you don't manage components, but Hilt will use a new instance. So when activity A is created, it will get a new instance of the activity component, and we'll use that instance to inject activity A. So activity B, if you launch activity B, it will get a new instance. So the component is one, but it's a class. So it's a definition. Then you will get, of course, at runtime instances of this component for injecting actually your activities and so on, and fragments and so on. So another thing to say about components in Hilt is that they live as long as the associated Android class. So the activity component will be created when the activity is created, and then the activity will be injected. And then when the activity is destroyed, the component will be collected with the activity. And also they have an associated scope, like activity scoped in this case. And this is just a Dagger scope. Is not something particular to Hilt, is not specific to Hilt. It's a Dagger scope, so it will work as a Dagger scope. The only Hilt related part here is that it's already provided to you by the library. You don't need to write the scope. So it's already there for you, you can use it. And just a small refresher on scopes in Dagger. A scope in Dagger is a way to tell Dagger to keep that you want to keep a single instance of your dependency inside the component. So let's say I'm providing foo and I use the activity scoped scope. So what will happen is that when the activity component is used to inject one specific activity, and you try to inject foo multiple times, you will get the same exact instance, because the scope will make the foo a singleton inside the component. And last part about components is that they already provide to you some default bindings. So let's say you need to retrieve the application to do something, so you can do so because the application binding is already in Hilt. You don't need to write it. Same for other classes, the other classes you see here. So these bindings are already there for you. You don't need to write them. Okay, so now let's see how to use it. So as I said in the beginning, I mean, the core is still Dagger. Still, you can use inject, which is actually from JavaX, and qualifiers, names, and so on. But there are a few differences, and these are the three main differences. So you don't need to write components. We already said that. There is a different way to associate a module to a component. And then there are utilities for injecting Android classes, which I guess is why we want to use it. We want to use Hilt. So you don't need to write components, so you don't need to do anything like what you see at the top, because in Dagger you wrote the component, you needed to manage the component, instantiate it, and make it available in the application. With Hilt, you just add an annotation, and you're done. And you will see that most of what you need to do in Hilt is add annotations here and there. So then the next point is injecting Android classes. And in Dagger, of course, there was no automatic way to inject Android classes. There was a way for Dagger Android, which was the previous iteration of a library for Android. So in Dagger Android, you have to write some code. In Hilt, what you need to do is just add an annotation, and then the Hilt compiler, the Hilt plugin will be generating the code for you to actually retrieve the component and inject the activity. You don't need to do anything else, just add the annotation. And then there is a new way to specify that some bindings needs to be available only in a certain subset of only for a certain Android class, let's say. So as we already said, we can associate bindings to the activity component, for example, or the fragment component, the service component. And we do so by using the install in annotation and specify the component where the bindings should be available. In Dagger Android, there was a different way to do so. And it's actually Dagger Android was more powerful. And this is one of the biggest differences and one of the biggest issues you will have if you try to migrate from Dagger Android to Hilt. Because in Dagger Android, what you could do, what Dagger Android was doing when you were using contributes Android injector, Dagger Android was creating a subcomponent for your specific class. So you could say these bindings only needs to be available in this activity. With Hilt, components are monolithic, so you cannot do so. So I mean, this is just a limitation of Hilt. I guess it makes Hilt easier, but it's still a limitation with respect to Dagger Android. And then there is a way to inject a view model. In Dagger, there was no way, in Dagger Android neither. And what we used to do in the past was just injecting the view model as if it was a regular class. But we also needed to add some custom code to properly retain the view model across configuration changes. Because of course, Dagger doesn't know anything about Android or configuration changes. So you needed to write some custom code to retain the view model. With Hilt, sorry, with Hilt again, just throw an annotation, the Hilt view model annotation, and you're done. The important part here is that when you want to retrieve the view model in the activity, you don't need to inject the view model. You need to use the by view models annotation because, sorry, the by view models delegate, because this delegate goes through the view model store and will properly store and retrieve the view model. So this is the critical part that will actually enable the view model to be retained across configuration changes. But yeah, in general, it's super easy. Just use the by view models and throw the annotation on the view model. And yeah, so this was, I mean, these were the main points for production code. So you should be fine with just knowing these small bits. Hilt is not that complex. But there are some benefits in tests, some big benefits in tests. So first of all, Hilt only works in instrumented tests. So roboelectric or regular tests on your devices. Not in unit tests on the JVM, but I guess, I mean, usually you don't need the full dependency injection library for your unit test. You shouldn't need it. Anyway, these are the benefits, at least the ones I see. So you have the ability to inject the test class, the ability to replace bindings very easily for tests. And then Hilt will also help you prevent state leaks across tests. And let's actually start from this last one. And to do so, we will look at the life cycle for an instrumentation test. So I don't know if you already know, but when you launch your instrumentation test suite, what happens is that the application is created. So the application on create is called, and then the full suite is run. So all the tests share a single application. This means that if you touch something which is shared, I don't know, a Dagger singleton, this state that you modify in a singleton will stay modified for other tests. So let's say test case 1 modifies the state in a singleton, then other tests will be likely affected. And I mean, if you wrote instrumentation tests, in particular UI tests, you know that your tests are already flaky enough. You don't need more flakiness. So we definitely want any help in preventing state leaks. So this is what happens with Hilt. So at the beginning, I said that the singleton component is associated to the application. So in production, there will be one singleton component for
blah, blah, blah.
Hello? Okay, so in production, there will be one singleton component per application. So only one singleton component. In tests, this is not the case because we want to avoid state leaks. So what Hilt will do in tests is creating a new instance of the singleton component per test. So every test will get a fresh new dependency tree with dependency providers and new singleton. So even if test 1 modifies the singleton, it doesn't matter because other tests will get a fresh new instance. So you cannot leak state if you pass through Dagger. Of course, you can leak state if you save state in global variables, top level variables, or Kotlin objects, but you shouldn't. If you pass through Dagger singletons, you should, I mean, it's not possible to leak state in that case. So to use Hilt in tests, you need to first do a small setup for the application. So you need to tell your instrumentation that it needs to use a Hilt test application, and this is true for all the cases where you don't have any specific need. If you have specific needs, which means you need to run some code when the application is created, also in tests, you can use the custom test application annotation. Of course, it's an annotation, and then you pass the class that you want to use in tests. So Hilt will create a subclass for your my app, and then you will need to use this generated class for running your tests. It's important to notice that if you go this route, your class cannot have inject tests, inject annotations, inject fields, or inject functions. Why? Well, if we go here, when the application is created, there is no singleton component. So there would be no way to inject your application. Actually, there is a way if you really want to, and it's called early entry points, but it's very prone to error, and you should use it only if you really know what you're doing. So I talked a lot about this app setup, but in practice, it should be easy the first time, and then you do it only once. Don't need to care about it. Then you need to do a setup per test. Just use the Hilt Android test annotation, apply the rule, the Hilt Android rule, and then you can use this rule to inject your tests. This means that after you call inject, your test will be injected with any dependency you want to retrieve. So if you want, you can have an inject late init var and retrieve any dependency at test time. And this is one of the first benefit we see with Hilt. And then there are ways to swap bindings for tests. So let's say that in production, I have my repository implementation, so production implementation, but I don't want to use it in tests. In tests, I want to use a fake repository. So what I can do? I mean, what can I do? So with Hilt, I can create a new module, a test module, as you see in the bottom, and I annotate this module with test install in, and I say, please, this module is to be installed in the singleton component, whatever you want, and then it needs to replace repository module, which is the production module. So when you do so, Hilt, the component that Hilt will generate for the test suite will provide a fake repository instead of the production one. And this is a simple way to replace bindings for the whole test suite. But you can also replace bindings for a specific test. So let's say you have a test where you want to replace the binding, then you first annotate the test with uninstall modules, and you specify what are the modules that you want to uninstall. And then you have two alternatives. The first one is creating a nested class, a nested module, where you provide your bindings, or you can use bind value. And bind value is a way to tell Hilt. So let's take this as an example. So bind value here, in this case, I'm annotating a field of type repository. And this is assigned to an instance of a fake repository. So what Hilt will do, it will provide this exact instance to anyone that requires a repository. So if a dependency in your graph, in your dependency tree, requests a repository, it will provide this value that you have in your test. So very easy. If you want to swap a dependency, you can do so in one of these ways. So this is more or less what I wanted to talk about. So now I want to look back and see if Hilt actually delivers on its promises. So simplifying DAG-related infrastructure. Sure, we see that throwing annotations here and there will just do magic and everything will work just fine. And then creating a set of standard components as scope. Sure, they are already provided by Hilt. You don't need to write them or create them. And then providing an easy way to swap bindings. Sure, we just saw how to do it for tests. So my personal answer is yes, Hilt delivers on its promises. But if you are deep in Dagger Android, if you are using or abusing Dagger Android, in the sense that you're creating a lot of components, subcomponents for your activities or your fragments. So you have bindings that are specific to a certain activity, a certain fragment, then you will have some troubles migrating to Hilt. It will be actually a challenge. But yeah, overall, it's a yes. So my advice is to use it. And that's all. Sorry, that's all. If you have questions, I'm here. If not, you can catch me later.
So thanks again for a nice presentation. So when talking about a simplification, so do you know, for example, how much code you were able to delete, or how complicated was the Dagger setup before, and how is it now after Hilt in the Glovo app?
I haven't measured it, but I know that, I mean, all the code that is related to components can be just deleted. The biggest benefit that I saw was with regards to modularization, because I mean, when you're in a Gradle module and you want to add something to your dependency graph, what you need to do is you need to expose a public module. So another module needs to say these components depends on this module. With Hilt, you don't need to do so, because inside your module, you can have inside your Gradle module, you can say this Dagger module needs to go in this component, and Hilt will do its magic and generate the code and link everything together. So you don't need to depend directly on your feature module if you want to, only for including the Dagger module.
Okay, thanks.
If there are no more questions, I have one, because maybe people is scared about introducing Hilt. So maybe you can tell us your experience introducing it and if it's compatible with Dagger.
So, when we started looking into it, we were a bit scared, because we still are using a lot Dagger Android. And actually this is an issue, because migrating everything is not easy, but likely you can have both. So they can cooperate. There is the option to have them cooperate. And if you go in the Dagger website, in the Hilt section, there is a full migration guide for you, step by step. So you don't need to do the full migration at once. Some did, like the Courier guys, the Courier team actually did the full migration at once. we went the other route. So yeah, you can just throw Hilt and then start using it and leave the migration for the legacy code for the future. Okay, I guess that's all. We have this QR that links to our engineering blog. So if you want to take a look, and of course, we are always hiring.
And now probably you are smelling the pizza. We have 2 Italians here. I don't know what they are going to feel about the Spanish pizza, but please come by. The best part, besides listening to these great speakers, is going to have some networking now. And remember the swag, the promo codes and everything as you go by. Thank you.